Good evening, everybody. Thank you for coming. I see that it's snowing. Again, we can't see the speaker. I'm glad that you were all able to make it, even though it is snowing once again. And the weather kind of did us in last week. So that was supposed to be when we were having Thomas speak. But I'm glad that you could all be here tonight. And of course, that Thomas could as well. So thank you for coming. My name is Kathy Bennett, and I'm the co-chair here with the Northumberland Learning Connection. And this is the final speaking event in the food series. Let's get started with the land acknowledgement. This place where we gather is located in the traditional and treaty territory of the Michi-Sagig and Chippewa nations. We offer our gratitude to the First Peoples for their care and teachings about our earth and our relations. May we honor those teachings. I'm very pleased to introduce tonight's speaker, Dr. Thomas Graham, Assistant Professor with the School of Environmental Sciences, University of Guelph, and Kansana Research Chair in Controlled Environment Systems. Dr. Graham has a Bachelor of Science in Environmental Sciences from University of Guelph and Stirling University, Scotland, a Master's of Science in Horticulture from the University of Guelph, a PhD in Environmental Biology from the University of Guelph, and wait for it, National Aeronautics and Space Administration, NASA, where he was a postdoctoral research fellow, Kennedy Space Center. And he doesn't look older than 30, so it's so annoying. Anyway, he has parlayed all of this expertise into controlled environment agriculture and bioregenerative life support for systems for long duration human space exploration, or as he calls it, space farming. And that's just one piece of what he does. And it's also about showing cutting-edge research and transforming good production in Ontario and across Canada. So it's quite the distance, isn't it? From Earth to space. Pretty impressive. From tackling food insecurity in remote and not-so-remote communities to applying space science here on Earth, Dr. Graham will explore how advancing and emerging technologies are helping farmers grow more with less through biological tools, big data, automation, and resource-efficient methods. So please welcome Dr. Graham.
Thank you, Kathy. Am I on? I am on. This thing on? Well, first of all, thank you everyone for accommodating me not dying on the 401 last week. It was much appreciated. It was much better drive. I brought the snow with me just in case. Anyway, I'm going to be all over the map here a little bit tonight with the central theme of controlled environment agriculture. But I want to start with, and these guys tell me the sound works, so it's on you if it doesn't. Anyway, I should mention, this is my lab, the Controlled Environment Systems Research Facility at the University of Guelph. And it's Earth, Moon, Mars, and all those good things. But I'd like to start with a bit of a montage, and I'll finish with that, which covers historically what controlled environment systems are, and most of the things I'm going to very briefly touch on tonight. So it was worth waiting. It was, I hope. epic. Go on. All right. You know how long it took me to get that to fade properly? Like hours. Anyway. So that sort of covered a lot of the things that we'll be talking about tonight and what my lab does, and labs all around the world for that matter, with a somewhat, at the start, disconnected theme of what does space exploration have to do with feeding people on Earth? But hopefully by the next hour or so, I'm tacking on the whole sound time, by the way, you'll have a better appreciation for that. So what is controlled environment agriculture, or CEA? Well, I'd like to start first with probably what it isn't, because there's a lot of misconceptions, and one is, it is definitely not this. This is nonsense. If you Google it, you'll see all sort of silly notions like this. That is not what we're going to do to feed the planet. Maybe in a completely dystopian world, hundreds of years from now, but this is not what it is. So just put that out of your mind. But I also want to touch on what it's not going to do, because that puts everything in context. Any farmers in the room? One. It is not going to replace field agriculture. That is a question I get, or a gut reaction is always, well, we can grow stuff outside, and why would we do it indoors? I say, absolutely, and we will always grow stuff outside. In fact, get into this a little later, technically this is controlled environment agriculture. This isn't what nature would have done. We are controlling an awful lot to make this happen. But for what I'm talking about, this isn't controlled environment agriculture. So before I get into what it is, though, I'd like to frame the question, and this is what AI, if I say make me an artist, this is what AI comes up with. But anyway. So at least it gave me hair. Anyway. So really what is, the question is, what are the food challenges we face? And that is a big question, and they are substantial. When it comes to producing food, we face a lot of challenges in the field. We've got weather, we've got critters, deer and raccoons, things eating, pathogens, pests, bugs, whatnot. And did I mention weather? Really did. Weather. I mentioned it, right? Right. Largely unpredictable and uncontrollable. Now, to varying degrees, we can do a lot of things. We can spray pesticides, herbicides, we can apply fertilizer, we can do a lot of things. As I mentioned, field agriculture is technically controlled, but for the most part, we can't do much about the weather, and it's getting worse. We keep pumping carbon into the air, and we're going to suffer the consequences. So events like this, weather, they're going to get probably more frequent, but certainly more severe. There's more energy in the system, so how could they not? So as a farmer, I'm sure you can appreciate this is not a good growing day. And if you do this 6, 7 times, 8 times over the growing season, there's going to be a loss in production, plain and simple. You can't avoid that, and we can't stop that. In addition to that, good arable land, which again, I'm going to keep pointing to the farmers, critical to what we do. Class 1, 2, and 3 land, well, in Ontario it's not so rare, but globally it's rare. And a lot of things are impacting. Climate change is certainly impacting. Land use changes, urbanization, water scarcity. Some of this great arable land is only arable because we put water on it, but we're running out of water, even in water-rich Canada. Soil erosion, globally desertification and salination, all these things are impacting how much land we have to grow with. Even conservation and protection impacts how much arable land we have. That's not a negative, that's a good thing. We shouldn't and better not cut all the trees down to grow our food or fill in all the wetlands. That's at our folly. It will destroy us. But it does impact how much land we have to grow our food. Well, and it turns out we're running out. Let's zoom in on that a bit. So this was UN data, 3 different studies. That's pretty wee. I think I got a bigger version. 3 studies, but all of them agreed we have passed peak arable land. There is no more. We got what we got. And we don't have enough currently. So we need other ways to supplement or help that along. We're still going to farm. We're always going to farm. Now, I don't want to be all doom and gloom. We've gotten really good about squeezing a lot of food out of the land that we do have. So in the last 60 years, that's quite remarkable if you think about it. There's a lot of, a green revolution. But obviously, this can't go to zero. We can't grow food on nothing. So that is going to plateau. Now, we might be able to push it out with some genetic engineering. CRISPR is a powerful tool. If we can get over our phobias of that, which we really should. But this all comes at a cost. There is good and bad ways to do things, but when you push the land that hard, you start to impact all these other things and make our arable land suffer. Soil erosion. So this is global. So we rely on soil. We need soil to live, to grow our food. Global, you don't see anywhere gaining in here anywhere, and some of them are losing a lot. So this is a problem that we do need to address. This is separate from controlled environments, by the way, but this is one of the ways that shifting some of our production indoors will help, but we do need to address this. I mean, we're not going to get into Dust Bowl era, certainly not in North America. We did learn our lesson. We are much better. Farmers are stewards of the land, but with externalities that are largely out of our control, again, we're not going to go there again, but we do got to be aware of it. And we are. There's a lot of work right now with regenerative agriculture, cover crops, low and no tillage. If driving down the road, if I see a field in the winter that's bare, heart breaks just a little bit. That life-giving soil is blowing away. So, but this is a movement that is gaining strength and hopefully will become the norm. Now, layer on top of all that, there's a lot of us. In my short life, well, not so short anymore, the population has doubled from 4 billion to 8 billion people. 4 billion people in my lifetime. That's a lot of bees. With those bees comes things, food security has become a major global problem. And these numbers technically, these aren't actually right. So ignore those ones. I give you the right ones later. But food security is a real challenge. And the more of us there are, the more mouths to feed. We don't have the land. Back to soil. This is just soil degradation. It's not erosion. The soils we're depleting them. We're sucking the nutrients out of them. We're not getting the carbon, organic matter back into them as much as we should. We are getting better. Again, I don't want to be all naysay, but water. Water is a big one. 2040. So you got places like South Africa that some of the cities are approaching 0 water days, where forget about the 70% of water we use for agriculture. They don't have enough to put in a cup to drink. There's nothing coming out of the taps. So that is a problem. Even water-rich Canada is still not, we're still kind of down in there. So water is a big problem, and wars are going to be fought over this. And again, there's a lot of us. We have to feed all these people. So a question I often ask my students, and I'll ask you as well. Show of hands, is Canada a food secure nation? Yes? Yeah, it's relative. No? There's no right or wrong answers here, by the way. All right, yeah, that's about what I usually get. So some of this might be a repeat from previous speakers, but it is, again, we're contextualizing where we're going in terms of controlled environment agriculture. So this is a lot of words, I'll just read it. This is food security. It exists when all people at all times have physical and economic access to sufficient, safe, and nutritious foods to meet their dietary needs and food preferences for an active and healthy lifestyle. That is a tall order. Based on that, I'm not food secure. Partly because chips are delicious and you don't know where they fit, but so that is a big order. But if we look at a slightly different version, food insecurity, we can get our head around it. And that is the inability to acquire or consume an adequate diet, quality, or sufficient quantity of food in socially acceptable ways. That's a big one too. Or the uncertainty that at some point you won't be able to do so. So I can guarantee I've been food insecure. Based on that, how many here have been food insecure? Read it closely. Probably at some point in your life. Anyway. All right, I think I got a bigger version of that too. Go. Canada. So this isn't even all, this is moderate to severe food insecurity in Canada. Even in Ontario, more than a quarter of the population is considered food insecure. In Ontario, the breadbasket and industrial hub of the country, here. Nunavut, 60%, pushing 60%. A strong majority of homes are food insecure. And I spent time, I did a lot of summers right about there, and I saw this firsthand. Luckily, I didn't necessarily experience it like they did, but it changed my whole perspective and outlook. And part of the reason I do what I do now is because of my time in the north where people have to live with that. So there's lots of impacts of this, besides, cute kids going hungry, which should make us all feel terrible, but food insecurity has a lot of impacts. So old Dougie here, he's always talking about improve health care and make the world a better place, but I got one message for Dougie. If you want to save 30 to 50% of our healthcare costs and make Ontario healthier, feed them. Plain and simple. So it's probably hard to see back, and these are older numbers, but I have some newer ones, but between food secure and severely food insecure, healthcare costs double, more than double. So back to Ontario, 25% of our population fits in these categories. How much can we save? We could potentially, financially, fix healthcare if we just fed people. Anyway. And it's getting worse. And here's the numbers. Now, this doesn't include the territories. So you can see that's not a good trend. So anyway, the doom and gloom will go away sooner or later. Just give me a moment. So part of it is cost. And so and we're living it right now. I go to the grocery store even 2 years ago. So how did it go up that much? And I got 2 almost teenager boys that are going to make it go up more. But there's a lot to factor into that. Global shocks, we got, this guy. One of his tariff tantrums causing just insecurity, uncertainty in the food supply. Natural disasters can certainly disrupt where we're getting our food. Could be a hurricane, could be an earthquake, could be a lot of things, and put uncertainty into the system. We all remember this one. Pandemics, chaos across. It might be that where you're getting it from, they can't do anything. They can't leave their houses to grow the crops. Who knows? There are a lot of implications there. And even relatively regional or small disputes. So when the Ukraine war started, what happened to food? The food price index shot through the roof. Okay, Ukraine's a breadbasket, so that was part of it, but we are vulnerable to all this because in Canada we tend to import a lot. This one shocks me a little because this is even 2000. This is before inflation went through the roof, and if you added 2024 and 25, it's probably way up here. So shrinkflation, all those things, we're spending more and getting less. So if you're on the edges in terms of a paycheck, is it rent or is it food? And that's a terrible position to be in. If you have kids and you have to decide, can I feed my children? As a parent, how devastating that would be, or is. And then there's always Canada, and there is winter. Look outside. We're not getting a lot of food off this field at the moment. So we are limited. So the question now is, what can we do about it? How do we address all these seemingly very large problems? But we can, I think. Simply put a plant in a box. There, I'm done. Now, you picked up, not happy. You can't just put a plant in a box. It won't like it. You've got to give it a nice environment, then it's happy. You need to control its environment indoors. And once you do that, problem solved. All right, now I'm gone. I'm not actually, because it's not that simple, because this is just a small piece of that puzzle. Those big, grandiose problems, they're not going to be solved by putting plants in a box. Controlled environment agriculture is not a panacea for all of that, but it is part of the solution, and it's a pretty powerful part of it. So now, we can get to what controlled environment agriculture is. I'm going to go back. It's not this. It's not replacing this, so rest assured. But this is, in a lot of ways, controlled environment agriculture. So what is it if it's not field? Definition time. All right, because everyone loves definitions, right? That's where you're all saying, I'm going to fall asleep now. Well, we'll get through it quick. Controlled environment agriculture, and I'm going to focus, it's both greenhouse and vertical farms or plant factories, but leaning more towards the completely indoor. But it's a technology-enabled approach to growing crops. Now, usually indoors, partially or fully enclosed structures, like that, which is, you'll see more about that later. It also involves, this is one of the key parts, it's the intentional monitoring, management, or control and optimization of these key environmental parameters that a plant, a little happy plant in a box, need to give us what we want, which is lots of good food. The goals of controlled environment agriculture are consistent and predictable growing environments, so no weather, or make your own weather. Because if you can get consistent and predictable growing environments, you'll get consistent and predictable output food. Resource efficient, that is the goal. We're not quite there yet on all fronts, but that is the point, is to be efficient with what we're using. And I want to maximize crop productivity, and that should actually be optimized, I suppose, because we'll get into it, but optimized doesn't always mean maximized. And of course, enhance quality, reliability, and safety. We want food to be safe. If food makes you sick, well then, all's for naught. So here's, in a nutshell. So these systems take weather out of the equation. We're doing it indoors, so they're independent of external climatic variability. Yeah, not that you'll ever beat weather, because the caveat of this is, if you're growing in a building and a tornado knocks it over, or a hurricane, or, okay, weather wins, but we get rid of most of the weather. But we also reduce the exposure to pests and disease and abiotic stressors, which ultimately means we don't have to apply things like pesticides or herbicides. We just keep the pests out. Now again, nature tends to always win. They can still get in, so you'd still got to be ready for it. But so what that means in the end, and this is a slide that I give my students, and it comes up so many times, they probably have nightmares over this particular slide, but you only get to see it once or twice. So maybe just good dreams. So here we have our crop, be it for medicine, because this all applies to medicine, food, or flowers. We just talked. So now it's in a box. You have all these things that impact what a plant becomes, how it grows. So I would mention, and I'll probably say this later as well, a plant, and this number is just thrown out as convenient, 50-50. 50% of what a plant becomes is its genes, and 50% is its environment. Nurture versus nature, all that fun stuff. You can have a set of genes, but the environment can turn that output on its head. And we can, indoors, we can control all of these things. And these are the big ones for indoors: water, nutrients, carbon dioxide, light, temperature, and humidity. Those six things really are the ones that we control the most or focus on the most because they have the biggest bang for their buck. But all of these and more play a role. Now, if we could just study plants in a box and say, all right, we're going to figure out the optimal temperature, that's great. Check. Light, check. Carbon, check. Got them all. Well, I probably wouldn't have a job because we would have done that years ago if those acted independently. But they don't. This is what actually happens. They all interact with the plant and with each other in this essentially chaotic system. Well, it's not chaotic because the plant can integrate all this and do its best. But if you change any one of these factors, you're going to influence all the other ones. And you've got to know what's going on to the best of your ability and appreciate that. For example, if we crank up the light, but we don't give it more carbon dioxide, your plant's not going to do so well, or you're wasting energy. Same thing, if you adjust the temperature, humidity can get out of whack in a hurry, and the plant doesn't do so good. Now, this is another version, and there's our little buddy back again. So now we're giving them this little gaffer all at once, keeping it nice and happy. This is the farm. This is what we're doing on the farm. But there's a whole bunch of externalities to that also impact, can we do this? Can we feed people with controlled environment agriculture? Or can we make the medicines? Or can we make the pretty flowers? So I'm going to be covering some of these, but there's a lot, and I don't want to bore you to tears, but there's a lot to this in the end. So that's the definition. So what actually is it? What is it? I think we all have an intuitive idea of what controlled environment agriculture is. Historically, here's some. It can be as simple as a cold frame where you extend the season. This is some cucumber production from the 1910s and 20s. Victorian-style greenhouses, or orangeries as they were often called, because they like to, guess what, grow oranges. So, a whole greenhouse dedicated to bringing an orange plant back. These are some of the older style greenhouses, not in use anymore. Now most of them would be, the gutters would be way up here. Now I grew up harvesting tobacco. They would often be started in these types of greenhouses, but again, not really used. If they're used now, it's more hobby or just not all the glass is broken and someone had one. There's also what are called hoop houses, so wire frames with plastic over them. These are essentially just season extending structures and allowing you to control water a little bit closer. But for our discussions today, they're controlled environments, but they're not what we're talking about. When I'm talking about controlled environment agriculture, these are the type of systems and the ones to follow that I'll be talking about. So we've got high wire greenhouses for tomato, the big ones in Ontario anyway, tomato, peppers, cucumbers. These high structures that take advantage of convection. Strawberry production in a greenhouse has actually come a long, long way. They don't taste quite like a Ontario outdoor strawberry, but they're pretty good. They're different. They're both very good. They're not the cardboard that they used to be. Come a long way. And we've done some work ourselves, and you can change how they taste. You can make them taste better or worse, simply by changing the color of the light, but I'll get into that. Here's just some more examples. In Ontario, right now, there's not enough sunlight for a greenhouse to work properly. So we do have to supplement. And there's a whole other side of that where light pollution and municipalities fighting with growers, but I won't get into that. The advent of LED technology, which I will show later, is from the space program as well. Now you can start to pump light into the inner canopy of the plants and stop those leaves from dying. Normally those would die because they're not getting any light. The light black in and that whole plant remains productive and productivity goes up. Just more examples. Talking of scale, this is Mucci. So if you've had a greenhouse cucumber or pepper or something from Ontario, it's probably from Mucci. strawberries as well. This is 32 or 36, 30-some acres under glass just for strawberries. And this is their expansion. They already had some. So there's massive production. The Netherlands, they are top of the heap when it comes to greenhouse production, controlled environment agriculture. For a relatively small country, they routinely are in the top 3, often at the top in terms of vegetable exports. And, you know, compared to Canada, they're about this big to us. But it's because of the high-tech advanced agriculture, controlled environment agriculture, where they can get those production levels. Second only to the Netherlands is us. This is Leamington, which is the most concentrated greenhouse production area in North America. And you can tell when, you know, this is an expansion. This is Moochie's again, but again, next to the Netherlands, we are it. We have a lot of expertise because Canada is a harsh climate, and we have to. If we have any chance of growing food in the winter, this is how we're doing it. So in terms of, I'm going to throw out these levels, and these are just what I tell my class. These aren't official levels or anything. It's just convenient for discussion. So we'll say controlled environment systems are level 1A greenhouses. Pretty high tech, but still they're relying on the sun. They're relying on ventilation for controlling humidity and temperature and all those fun things. Still advanced. On the other side of that is containerized crops or controlled environment systems that are open. Here's maybe a better example. So growing in a box, still using electric lighting, but we're not really protecting them as much as we could. So that is our level 1B. Same as the greenhouses, except there's electric light. Not a lot in terms of, so we've got minimal closure, some automation, some electric, or it's all electric lighting. Now we bump it up a notch. Now we're into these large-scale, often large-scale commercial operations. Vertical farms is a terminology we hear around here, but if you're in Japan, it's plant factory. Plant factory is probably a better description, but it is what it is. So we have these multi-layer, indoor, highly advanced farms. Just some more examples. More examples. Not looking like a farmer's field, obviously. Pretty sterile. They're not sterile, actually, but clean. But this is a farm, by all definitions. So these are our, what I call level 2s. So they're plant factories, sealed or highly closed chambers, not necessarily completely sealed. At least a bit of baseline automation in most of the loops, and I'm going to mention loops, like the water loop. When I say close, it means we irrigate a crop, catch the water, treat it, and bring it back. Round and round and round. And third level is, well, this is my lab. They're pretty closed and sealed. But what are known as the bioregenerative life support systems, and I will get into that. Now, the innovation and how we're feeding ourselves with these, it's not stuck, it's not top down, it's a flow. What we learn here is applicable to space, it's applicable to these, and vice versa. Everything we do in space, growing food in space, is immediately transferable back to Earth. Because if you can do it in space, you can do it anywhere, as the saying goes. Well, my saying. You can be yours too if you want. All right, so now, unfortunately, this is a bit of a promotional video from one of our partners, but it does capture nicely when we're saying advanced controlled environment agriculture for feeding people. These are the kind of systems, and there's others like it, but this gives you a sense of the scale, although this is one of their smaller ones, but the kind of technology that we're talking about. And I apologize, this is less epic soundtrack. I didn't pick it, but. So again, their newer ones are almost double this height.
Hi, I'm Amin Jadavji, the CEO of Elevate Farms, and I'm excited to show you our fully autonomous vertical farming operation here in New Jersey.
So we've been working with Pear, this guy, for 15 years, and he started as a lighting company and took what we knew about space and the science that we did on just growing plants in a box and ultimately got here, which was the basis of a synergy award that we were just awarded. And these are all in one, so these are still going into the production system, but they come off the production system, they go into cooling and packaging, and it's all self-contained. And this one is in New Jersey, and it's in the middle of an industrial complex. So I think there's a bakery next door, I believe. So I'll get into this, but the work we do in space, immediate transfer to terrestrial applications. And you might notice this all lettuce, and we're not going to feed the world on lettuce, admittedly. A lot of the work we're doing right now is expanding the offerings to things with more calories and more nutritional content, but got to start somewhere. Yeah, so 200 kilograms per year, maybe as a farm for a meter square, you might appreciate that's a lot of lettuce for a square meter. All right. So that brings us to the promise of controlled environment agriculture. And I just throw this up here. There's a book chapter I wrote that covers all this. If anyone's interested, I certainly send it to you. So, and that's not promo. I get nothing for it. So I didn't get nothing to do it either. But back to water. Controlled environment agriculture saves a lot of water relative to irrigated field. A rain-fed field, no comparison. But if you're comparing a field that you need to irrigate to greenhouse and controlled environment or vertical farms, it's a sizable savings. Greenhouses up to 70%, vertical farms up to 90% less water per unit produce produced. Now there's lots of ways we can do that, which I'll get into. But at the end, I also have some, I'm not sure how this goes out to people, but there's some links. There's a wonderful video series, and no one in the back can see that. But anyways, Cognition or something like that. 4 or 5 part series on vertical farming that covers everything way better than I ever could in this hour. But just to put it into perspective, go back one here. So this is astonishing. So a kilogram of lettuce in the best, most efficient vertical farms, they can do with 1.2 liters of water total, which is really saying something because lettuce is almost all water. It's about 94% water. So that is suspect maybe, but it is doable under the right conditions. And I'll show you how or why. Oops. Now compared to greenhouses, which are also pretty good, 20 liters per kilogram is not bad. Now compare that to a field production, irrigated again, 237 liters per kilogram to produce that lettuce as well. So there's some real potential to address that water issue. Now it's going to have to be at scale. That's a challenge in itself, but this is just a quick video on how this actually works. And the sound doesn't work again. Switch me over.
Did you know vertical farms can use up to 90% less water than traditional farming? Here's how. Instead of soil, plants grow in hydroponic systems. Roots bathe in nutrient-rich water, not dirt. And that water, it is collected, treated, and returned to the production system. But here's the cool part. Plants lose a lot of water, most of what they take in fact, through the process of transpiration. In a vertical farm, that moisture doesn't disappear. It can be captured by the HVAC system, condensed, treated, and returned to the crop production system, along with the recycled irrigation water. Every drop gets used, reused, and used again. Much less and highly controlled runoff. No groundwater pollution. Just smarter, water-efficient farming. Stacked sky high. Vertical farming is part of an ongoing agricultural evolution, a more water-wise way.
So that's how you save water in a vertical farm. The numbers that you hear if someone said, oh, we saved 90%, there's some caveats to that, and it's usually a little bit of BS, because they're not including processed water or flushing their toilets or anything like that. It's just the crop production. So it's actually not that much, so buyer, you got to be careful. Back to our issue with arable land impacts. So this is this is really small, but don't worry about any of that. This is the classification of Ontario's agricultural lands. 1, 2, and 3 are good. 1's the best. Beyond that, so these greens and yellows, they're not so good. They're marginal lands. You've got to do a whole lot. You got to pump in fertilizers and all sorts of stuff just to get them not even close to class 1, but just to produce something. Maybe we shouldn't use them. Maybe they should return to being, buffer strips or other things like that. But then we run into the issue that it's still not enough land. So what are we going to do? Well, it turns out all land is arable when you're inside. This is arable land in a vertical farm. So there's nothing stopping us from slapping vertical farms up anywhere. So we don't have to cut down more trees or fill in or drain wetlands. We can even let some of the agricultural land that's just not that good and it's just way too much work for the farmer, give it back. Let the trees grow, let the grasses grow, or use it for something else. And replace it on, these highly productive ecosystems right here. Now, the other thing is you can do it anywhere and any time. So here it is, perfectly productive farm in the middle of winter. We could have it out there and we have fresh salad. Okay. You need some ranch dressing to get the calories in there, of course, but we can do it anywhere. And in fact, we do. So this is Molly. She was a former student and again to be future student of mine, but she took a job in Alert, which is the most northerly human settlement on the planet. And since she was with us, she had a passion for controlled environment agriculture. She was up there monitoring the air, which she tells me even up there is really dirty, so we got to fix that too. But she got the Army to give her a shipping container that was just rotting away, and she turned it into a farm. So now the base has some fresh salad, which in the middle of winter up there is hard to get. We've done it in the South and Antarctica as well. This is a project a lab was involved with when they had to take a picture of the penguins to prove it wasn't the Arctic. Anyway, same idea. This is the German Research Center, Nuremberg 3. In this case, the first 2 fell into the ocean or got covered in snow. Because this is actually out on the ice sheet. It's not on land. But again, there it is at night. Quite pretty. But they have a food insecurity issue as well. So in the Antarctic, when the sun goes down, you don't get out. You get 6 to 8 months, no one's coming to get you. Don't break anything, don't get sick. But those are your shells start to look like lots of calories. I mean, there's probably enough calories in the ketchup to keep them going, but that's kind of boring. So what we were able to do with this, it was being modeled as a space station application originally, but we fed them, and we sent poor Paul here down and left him. But so middle of winter, you're isolated, stress levels are pretty high. Having a good meal, remember the healthcare thing, can go a long way. And several times a week, Paul would bring this in, and they would sit down and they would enjoy a nice, fresh, healthy meal. So it can be done pole to pole. But it can really be done anywhere. Slap it on this is Louf up in Quebec, greenhouse on the roof. This is Goodleaf Farms in an industrial complex in Guelph. I forget where this is, but you can put them right in a store, you know, hyper local. And again, just drop them in a parking lot. Now, I did mention that vertical farms can also reduce the requirements for fertilizer and corrective chemical inputs, and that's just a nice way of saying pesticides. But to avoid issues like these algal blooms or runoff, this is all in a, well, farmers don't like to see that because that's their nutrients in soil running away. But so again, I'm not by any means bashing field agriculture. Absolutely needed, and precision outdoor agriculture has really come a long way. It's incredible what can be done to each plant getting just the right amount of fertilizer or pesticides or herbicides, whatever it's needed, can be done. And we are getting really good at that. But you still have to do stuff that's outside. Now, indoors, you can apply drones and all sorts of things and take little zappers and kill bugs. So it's kind of neat. That is just emerging, where half the times he's probably flying into the plants and knocking them over, but it's a work in progress. But one of the strengths is when you put plants in a building and you close the door, you now have control over what comes in and out. So that means you can control the air. You can block everything, filter it, throw some UV into the ductwork, ozone, whatever you want, something that kills stuff to come in, you can block it. So if you've blocked it from coming in, you don't need to kill it after the fact with corrective chemicals. But these are the 10 dirtiest things that will ever go into a vertical farm. So people are the problem. So you can either automate the crap out of it and hope they don't go in, but you can also treat it as a cold room or a clean room. So a lot of these places will have, you know, air showers, disinfection systems as you go, lots of biocontrol or biosecurity stuff. But this is a farmer. That's how they dress. But they are farmers. She is a farmer. Probably stock photo. I don't know who that is, but that's what they typically look like. Okay, so we talked about the goals of controlled environment agriculture. Now, I'm going to jump into some of the work that we do, how we try to meet these goals. And this is just a shot of part of my facility. These are some big fancy chambers that we made for space, but now we use them for Earth. These are just nice rainbow. It's one of these, but nice pretty pictures with lots of, this might just look like a rainbow, but just changing the color of light that you grow a plant under has profound impacts on what it tastes like, looks like, and I will get into that in a moment. But going back to this, so now my lab, we study all of these things and how they impact how we make food. So for example, you know, I'm a scientist, so I got to show a graph at some point. So on the y-axis here, it's called net carbon exchange rate, but think of it as photosynthesis or productivity of a plant. Across the bottom is the amount of light. Now for reference, it goes up to 1,200 micromoles. If this was outside in June, full sun would be out here somewhere. All right. So one thing to notice, when people say, oh, we got to replicate the sun indoors. No, you don't. A quarter of it's plenty. It's already plateaued. Plants spend a lot of time dissipating all that extra energy, by the way. Anyway, the point of all this, so we've got light. So when we're indoors, we can do a lot of things to really push a plant hard. So 2 different light levels. If we just increase carbon dioxide from, well, triplet, from 400 to 1,200, we pretty much double productivity. And that's a pretty common ratio. Triple the CO2, double the productivity. Add more light, same thing. Now you can do both. You can add more light and CO2. So remember, this is this would be a really cloudy field day. But your productivity, just by changing one of those factors, can go up dramatically. But when you do that, it changes how a plant feeds. You got to fertilize it different. You got to water it different. You got to do all the other things differently. But this is how we get these big numbers out of these indoor farms, because you can contain it, you can crank up the CO2 and get that high level of productivity. With the advent of LEDs for horticulture, we've got this amazingly powerful tool at our hands now, from both a scientific perspective, but also from a production perspective. So this is, it's actually a prototype we made for the Kuwaitis, of all people. But we were testing it out. We just grew lettuce under red, white, and blue, just for a lark. And this is what you get. Genetically, the same. It's from the same seed pack. Grown under white light. This is what it's supposed to look like. It is a red romaine variety. But that's what it looks like under normal white light. If you grow it under just red, it says what's happening is the red color is anthocyanin, which is essentially, think of it as sunscreen for a plant. So normally it's producing this to protect itself. It's a little bit of a stress response. But if you take out all the blue light, or UV, but the higher energy light says, I don't need to protect myself. Plants are very parsimonious. They're not going to make something that they don't need. So they don't. Now, if you grow it in a lot of blue, it thinks, oh, geez. So it really cranks it up. Now, that chemical is, for us, an antioxidant. So technically, this is healthier if you're thinking antioxidants. The trade-off, because there's no free lunch, this one's twice the biomass. So, biomass, so it's twice as big. But there's also more difference. This one has thicker, crunchier leaves. These are kind of floppy and it doesn't taste like anything. And this is somewhere in between. If you close your eyes and take a bite of each one, 100% certainty you will say red, white, or blue without fail. Just by changing the color of the light. Nothing else was different. So we have this godlike power to manipulate plants for what we want. Now, when we're talking medicine, that purple could be a medicine too. So you can start to improve medicinal qualities of plant-based medicines, which account for 60% of what we call medicine. Breeding is a big part of what we're doing now. My lab's not really into molecular biology too much. We like to play with the plant, the whole thing. But there is a lot of work now breeding for vertical farms. So when you're breeding for outdoors, you're looking at disease resistance, drought resistance, resistance to the environment that's trying to kill them. Indoor, we have control over that. So we don't have to breed for that. We can breed for the other things. But just to show the plasticity, or the potential, so this is Brassica oleander, the progenitor, essentially a weed. So whoever thought we should start breeding this is really smart or insightful, because these are all, guess what? They are all the same species. They're not even, they're just varieties that have been, different parts have been selected for the same species. So you let them flower and check out the flower, identical. So there's a lot of potential in breeding. Now for controlled environment systems, again, we're breeding primarily for two big things right now is short. We want them short because you saw these stacks. You want to be able to squeeze as many in as you can. The other is we don't want to be wasting resources on making stuff we can't eat. That ultimately becomes waste that we have to, well, it's not waste, we want to recover it. But for example, lettuce, one of the reasons it's commonly grown right now is because you can almost eat the whole thing. It's like almost 90-some% edible. It's just a little bit of the roots and some cuttage. You know, something like beans, for example, though, most of it is stuff we don't eat. So we're breeding for dwarf architecture. We want plants small. We want more of the plant to be something that we can chew on. And we want them to be more nutritious, like that lettuce. And very similar to that, more flavorful. We can make them taste different. Again, we've screwed it up in the lab. We've made them taste horrible, but you can make them taste better too. So this just taken from a paper. If you can make the plant smaller, you can get more stacks in, and you can get even more efficient. And there's lots of examples out there. Dwarf varieties exist, not necessarily commercial, but And these mutations happen all the time. We just don't select for them, but we are starting to. So as you can see, very productive tomato plants. This is one that I stumbled across when I was at Florida. I was growing a whole bunch, and this one cropped up just randomly. Random mutation, who knows? I kept it around and was trying to grow it, but somehow it got lost, and I don't have any seeds, but could have been a millionaire. Anyway, but the point here is these are small, but they're still highly productive. You know, there's a bit of a trade-off, but we can do, and I apologize, some of this is quite grainy, but we can also do a lot with molecular biology and just tweaking some genes. And I won't get into this one in too much depth. This is Kwan et al. But in tomatoes, how many gardeners? Lots. All right. So, you know, your summer tomatoes are indeterminate. They just keep going, unless well, some varieties don't. But if you're going to do that indoors, that big vine structure isn't necessarily what you want. So with just some relatively minor tweaks, just 1 or 2 genes, you can take it from this indeterminate big viney thing down to this big short little cluster just full of fruit. These are minor changes. And there's a clearer picture, but so that's what we want indoors. Would that be viable outside? Probably not. Other things would grow over and outcompete it. Another thing that I did while I was doing my postdoc is I was working with NASA and the USDA, and I have a whole lecture on this one, but someone asked what one of my favorite projects was. It was this one. So this is a plum tree, and long backstory, plums are attacked by plumpox virus. So the USDA was tasked with fixing that, and they developed this whole breeding system that tweaked one gene again. And they didn't even change it, they just turned it on all the time. So genes often come on and off at certain times. They said, oh, let's just turn this one on all the time. When they did that, so this is a normal plum tree, it's about 3 or 4 years old. It won't produce fruit for another couple of years. It'll be, up there. They took this one gene, which ultimately is controlling flowering, and they turned it on, just left it on. And this is what they got. So you can notice it's flowering already. These things are only 6 months old. They're already flowering, already doing all sorts of stuff. But another neat thing is, this you do not see in nature, not in temperate fruit trees. We essentially made this like an indeterminate tomato that you would have in your garden. You see mature fruit, immature fruit, and flowers all in the same fruit tree. That does not happen. They changed one gene, and I said, they just turned it on. They didn't even change the gene. But I think I'll get back to and you can change if it's vegetative or reproductive just by changing the temperature. So lots of really neat stuff going on. Okay, so there is an elephant in the room, though. No, I agree. A colleague of mine in class repeated, and it ends up being a quiz question, is lettuce food? And the answer is no, but according to him. Until you put the ranch dressing on and put all the calories on. But we are moving towards, and that's some of this breeding. So those, for example, that plum tree, there was a vertical farm that was looking at trying to see if they could do that indoors because it becomes continuous production. Energy, that is a big one. Lights cost a lot to keep on. HVAC's expensive. Plain and simple. Now, yes, we got to work on it. Our energy supplies the price even needs to come down. That is a bigger picture, but certainly applicable here. But on the, hey, we're getting there front, the LEDs that are driving these, the efficiencies are increasing rapidly. It was 20 years ago, these things weren't even considered useful for horticulture. Now they are the go-to because they are highly efficient, tunable, and you don't have to give all the colors. You give the ones that we can. The reason you see these magenta greenhouses with that horrible colored light, which hurts my eyes, is because blue and red LEDs are efficient, but it's also what chlorophyll absorbs the best. So the initial idea from NASA was let's just give red and blue. When you combine red and blue, you get that awful color. Sorry if you like magenta, I just don't. But But we have since learned that we should probably add some other colors back in because plants do use it. And no agriculture is going to be truly sustainable long term if it's on fossil fuels. Green or CA is no different. But the cost of all these other carbon neutral and green and sustainable energy source is coming down. So I'm not going to solve the energy problem, but once it's handled and it's cheap enough, these things will be sustainable. And that argument, in fact, the LED reduction in price has already shifted some to the labor being the most costly part of a vertical farm, because you're paying farmers as well, but also fancy engineers and whatnot. But so, does it work? Just some examples here. I'm probably getting a little on time, right? Yes, give me the stink eye. All right, Churchill, Manitoba. Winter, same issue. They got to fly stuff in. So inside that box, this is what it looks like in the middle of winter. Now, I'll read this because I don't actually can read it at the back, but read it from here. So in the town of 800, perishables need to be flown in, making produce expensive. A head of lettuce at the grocery store in Churchill is about $7, but by the time it arrives, it's often wilting because it's come a long way, probably not stored properly, and its freshness and its nutritional value are pretty much gone. She can grow and produce lettuce at $3.50, which is still a little bit expensive, but it's fresh and it's on your table the same day. It works. And there's also some social components to it. So they're putting variety into people's diets, so different nutrients, different choices, and it's bridging some cultural barriers. So I'll read it again. We've been showing people how to cook this pak choi. They're putting it in stew, she says. It goes great with caribou. So what is a culturally relevant food? It's what the culture wants to eat, ultimately. So this is bridging. Again, I'll just speed along a little. We also did it in Joy Haven, which is way up there as well. Same thing, brought the local community in. This was a Canadian Space Agency and Agriculture and Agri-Food Canada project. Won't read all of that, but except for this. At the beginning, it was really confusing, Kovic said. We didn't know how to do it, but we've got the hang of it now. And in the spring, Sammy, her husband, says he wants to travel to that place to help the community start their own. So there's some grassroots, but it can be done. This is a video I'm not going to play, but again, I'll post the link. This is just a heartwarming story of a community. Started a vertical farm. The kids at the high school make the meals. Everyone's happy. I'll send the link. It's really heartwarming. Another video that I won't play. Mr. Dyson. If you want where we can go with things, this is a wonderful video on, so he has a greenhouse or a vertical farm, but he's tied it in with sustainable agriculture, so it's traditional farming. They take the waste biomass from that, do anaerobic digesters, use that to power things, heat. It's just a full circle kind of story, but again, I'll include the links, because this one's a little bit longer. All right, I'm getting there. So, to boldly farm right on his farm before we get here. I know space is in the title, so you may have been waiting. I almost put Captain Kirk's face on it, or Jean-Luc, yeah. All right, so bioregenerative life support. That is a big chunk of it's one of the pillars of the lab and some of the things that I've been studying for quite a while now. And here it is. So I'm going to spend the remainder of my time going through this. Don't worry, you need to sleep. Yeah, this is the look I get. Gotta love Lucy. Yeah, it doesn't have to be that complicated because it's just farming. Not just, it's space farming. Farming is tough, as you know. But doing it, that is how we will keep people alive in space because it's how we keep them alive here. We are going to grow food in space because it produces, keep moving along here. it produces all the things that we need, plants do, in associated biology, all the things we need to keep ourselves alive. So, who's seen it? Who's seen The Martian? Well, now you all have to go watch it now. Okay, there's some less than accurate stuff in it, but the plant part is actually quite accurate. The math that he does, and some of the things he does, playing with his compatriots' poop, that's all legit. And it kept him alive until, well, I don't want to spoil it. So it kept him alive. So it's pretty straightforward. Okay, I talked to grade ones as well, so anyway, it's effective. So on Earth, although Earth is a closed system as well, we don't think of it in our short existence. But we take in air, oxygen, food, water. We breathe out carbon dioxide, we pee and we poop. Biology 101. And a bunch of other stuff. But in space, if this is waste and you're just getting rid of it, well, then you need a lot of this. And unfortunately, a lot of that is, okay, this is your spaceship. You can't carry that much stuff. You are limited. The currency of space is mass and energy. You are limited by mass and energy. You can throw as much money at it as you want. It doesn't matter if it's too heavy. So we need something. We can't just keep taking stuff up and then throwing it away. And yes, I do this to my kids, but anyway, they're the spaceship. So we've got a lot of behemoth rockets now. In the last 10 years, our capacity to put stuff into space has increased immensely. So that is NASA's SLS launch system, massive rocket. This is SpaceX version, even more massive rocket, the most powerful thing ever built. Jeff Bezos' Blue Origin, another massive rocket, not quite as massive, but we now have capacity to still lift a lot of stuff, but it's still not enough. If we have to just keep resupplying, we're not going. We'll send the robots. If we can't have a regenerative system, something that just round and round, we're not going, plain and simple. Turns out we do. Plants. Plants and, again, associated microbes, because nothing's sterile. So this is the same system. So now, here we are, breathing in oxygen, drinking water, eating food, pooping, peeing, and breathing. Okay, instead of waste, that is now food, with a little bit of processing here, but this is direct. The plants and the biology take our waste and generate food and clean water and oxygen. All we got to do is provide some energy. That is biological life support on the Earth and in space. Now, this isn't new. Joseph Priestley in 1772 figured it out. I don't know if any of you remember, probably high school biology. Anyway, quick experiment. He put a plant, sealed it in a jar, died. Put a mouse in a jar, sealed it, it died. Put them together, they lived. So he essentially figured, he didn't know it at the time, photosynthesis and respiration. The plants produce oxygen, the mouse produced the carbon dioxide. Plant died, it didn't have enough carbon dioxide. Mouse died, it didn't have enough oxygen. Put them together. Life support. That's it. So the role of plants and all that, so food production is the big driver. You got to feed people. But in doing so, there's more than enough oxygen produced, scrub more than all the carbon dioxide that we're barfing out. A major component in recycling the water, because a plant leaf is just a little evaporative surface, a little distiller. The water coming off, it's left all the bad stuff behind. So we just condense that water. So we can use the plants to treat our water. Certainly psychological benefits. So imagine 8 of you stuck in half of this room for 3 years without any sort of other biology and smelling everyone else and all that. Even astronauts on the station gravitate towards the plant experiments. It's the notion of biophilia and things like that. But there's other things as well. Countermeasures, which I'll get briefly into. Medicine, plants can be medicine. You can use them for structural things. Mars, for example, has not much atmosphere, less than 1% Earth, but what is there is carbon dioxide. So you can harvest that, make fibers, put it in Martian concrete or make a new shirt. Now, NASA has been working on this for years. Back in the 80s, there's the biomass production chamber, and I stole these slides from Ray Wheeler, who was also my mentor at NASA, so I'm sure he'll forgive me. This was an old vacuum chamber from the Apollo or Gemini era, but they converted it into, and there's the tech of the time, but they converted it into what is probably the first example of a vertical farm. The term didn't exist then, but they were limited in volume, so they stacked layers of plants in this big round dome. And this is it kind of looking down. There's actually another layer, but again, NASA space program came up with vertical farming way before it was ever coined as such. Potatoes. Before the space program, they didn't think you could grow potatoes hydroponically. Turns out you really can, really well. And with the added benefit that when you grow them hydroponically, they're disease-free, or you can keep them disease-free. So seed potatoes now, when you get them from the store, are grown hydroponically, and that came from the space program. So on the Martian, when he's eating potatoes, NASA has a long history. In fact, Ray was interviewed. Anyway, Ray was the potato guy. We've also shown, again, back in the 80s and 90s, you can take the waste biomass, put it through a biological digester. You can't do it directly. You do need to treat it, but with biology. And okay, it's a weird color, but grew just fine. LEDs, the thing that are driving controlled environment agriculture now, and all of this. For horticultural applications, started with NASA. They needed a light for shuttle missions and whatnot. It wasn't a high pressure sodium, which is the ones you see in greenhouses, but also street lights. That bulb is about 1,000 degrees. So you're not going to put it that far from a plant unless you want crispy plants. Fluorescent tubes, decent light, but what happens when they break? You get mercury vapor and glass shards in microgravity floating around in your eyes and all sorts of things. So they needed something. LEDs were not that efficient back in the day, but they met those other criteria, so they started pushing it. So in the first patent, I can't read that, but the first patent for LEDs as a horticultural tool was 1990 out of the University of Wisconsin on a NASA-sponsored project. Now they are the go-to for plant production. Now I just want to end with space. Everything in space is trying to kill us. It's not a very hospitable environment. So a lot of effort by the space agency goes into countermeasures. So what do you do to protect us from all these things that are trying to kill us? Well, it turns out, well, you've probably seen astronauts are always exercising on the space station. So their muscles and their bones are always being pounded on to stimulate them to stay strong. But you can do things like add plants to your diet. Plants can be medicine. And again, whole lectures on this, but you can do molecular farming, but I'm going to focus on nutraceuticals. Remember these guys? These plums that I was so fascinated with? Turns out, they were hiding a secret. So when we started working on this, had a meeting with this guy from Chris Dardick from USDA, talking about these plums and how they're meeting all these criteria for spaceflight. That's awesome. He goes, oh yeah, by the way, one of my colleagues turns out these things are great for bone loss. I said, what? Because on the station, astronauts suffer the equivalent of severe osteoporosis. They're losing about 1% bone density per month, which is severe. That's even with the exercise. Turns out that, this is my public service announcement, dietary supplement with dried plums, not only keeps you regular, it's been shown to reduce bone loss resulting from exposure to space flight, but also right here on the ground. This is real. It's more effective than any pharmaceutical that we're aware of. So just real quick, this is an experiment by a colleague of mine, Brenda Smith. So this study, so these are CT scans. So this is a control, and this is a little bit cruel, but okay, they took the mice and they took their ovaries out. So they induced, not unlike menopause, but without the hormones, their bones started to deteriorate. So here's normal mouse. Here's one that's hormone deficient because of the treatment. So again, strong bones red, weak's blue. So quite the difference. They fed these mice a diet of dried plums, a little bit and a lot. Eat your prunes. Sorry, dried plums. We've changed the names. Anyway, so these are all things that space application and controlled environment agriculture, growing plums, all have to offer ground applications.
Is it dried plum or prune?
Yes. Prunes have sort of associated with other functions. So, yes, we're going to call them dried plums now. So, yes, they can be, but just a handful can certainly help. So, I started using them. Anyway, I got all sorts of those little gems. But so, the long and short is space certainly has trickle-down effects and applications immediately on Earth. So spending money in space, there's a misnomer. We have never spent a single dime in space, unless the astronauts are, gambling or something. It's spent here on the ground, paying people who pay taxes to develop technologies that ultimately impact and benefit us. So with that, sound guy. Hopefully this means more. Ready for the crescendo. To get that fade, I made you listen to it twice. So.
So, Thomas, thank you so much. That was a fascinating presentation. I knew nothing about this subject before we started the planning for this series, and I did try to read some of your research, and I didn't understand it.
Me neither.
So I also want to thank you for not only a fascinating presentation, but taking such a complex topic, subject matter, and making it understandable. And boy, am I thankful we have the notion of controlled environmental agriculture. I'm really thankful that we have this, especially with all the complex problems. And I'm really thankful for big brains like yours right here in Ontario working on it. So at that, let's take a few minutes for some questions. And do we have another mic so we can run around and, all right. Hands up that were over here. I think I saw yours first. You go first.
So I made a comment about we're not going to feed the world on lettuce.
Right.
Is
You're right.
anyone working on protein-based plants, Can we grow grains in this environment? Can we do quinoa or anything that is higher protein for the rest of the world? Because these plants are, I love lettuce and strawberries and tomatoes and whatnot, but they're not going to sustain us. And I don't think they're going to sustain people in space either.
No. Now, in space, we have the luxury that cost doesn't really matter. We need to keep people alive. So yes, I could show pictures. We can grow wheat. We can do it all. The short answer is we can grow anything indoors. Can you do it economically here? But yes, we're currently working on, well, right now we're bringing field crops in, so we've worked on beans and a bunch of other things, but short answer, you can grow anything. It's the will and the expense. The longer the crop takes to mature, the harder it is to make money. But there is we're looking at mushrooms as well, insects. So if you go to space, if you're not going to be a vegetarian, you're going to be eating bugs. So that would be your protein to start. But there's benefits of that because the bugs can help cycle the stuff that we can't eat. They can help cycle it quicker, so it can shorten the timelines. But you're right, we're not going to feed the world on lettuce, and we have to change. And that's where some of the breeding, that's why I brought in that breeding. We need to breed for more efficient, smaller, more compact things indoors that do meet our dietary requirements, because, yeah, lettuce ain't going to cut it.
My question is about the energy input. And we've been talking a lot about energy in Canada lately with the pipeline. And we've also been talking about energy. Canada's going to be the big energy power, and we need it for artificial intelligence. And I see a lot of competition with future innovations for energy. And you showed that one graph, but how does this fit into any limitations on enclosed environments?
So in terms of energy supply or the mix that we're currently working on?
Yeah, and energy supply, because all the big computers are going to take a lot of energy too. So there's going to be competition for energy production in the future.
Absolutely, and energy is certainly a societal issue, not just controlled environment agriculture, but I am working with a group out of McMaster, actually it's across the country, looking at other energy sources, focusing a little bit on small modular reactors because McMaster is known for their nuclear program. So some of these can supply a community. So on this, when we consulted with the communities, these I call them northern and remote communities, but they tend to be mostly indigenous, but not exclusively. They said, keep us warm, and right below that, in terms of priority, was keep us fed. And that's why I was brought in on the project. Everything else is gravy. So yes, the energy question is that elephant in the room, needs to be addressed. But there are ways to get there. And in the meantime, the offsets benefits of the other things hopefully can push it. But right now, running on a fossil fuel supply, they are not sustainable, but nothing is, ultimately. So, no, we need to figure that out. So. I can hear you. I can come over and you can whisper in my ear.
I noticed in one of the slides there were some solar panels, and I was wondering whether solar farming is being integrated with what you're doing.
Yeah, and one of the criticisms, so if you're going to do it with solar, which is certainly the cost is comparable, you do need a land area for that. And say, well, if I'm going to have to put 2 hectares of solar panels to power 1 hectare of farm, it's not all that, where's the balance? I said, yeah, there's a point to that, but that's a little bit short-sighted because you can put them anywhere. There's agro photovoltaics, so let your sheep graze around. There's ways, take that marginal land that I was talking about that's not, unless you're pumping a whole whack of fertilizer and doing a whole bunch of stuff to get it to work, put them there and let it be grazing land instead of high intensity staple crop production. So yeah, there's always a gray zone, but you can do it with solar is a good energy source. It's one of the cheaper ones now. So is wind, geothermal, all these. It'll be a mix. If we just pick one and go, that's at our detriment. So.
We'll take one more question.
Yeah, I was just referring to this lady's comment before about the government's telling us we're going to become a energy superpower. Can we, as a country, become a food superpower eventually?
I think we're
on the way.
Pretty close there already. Now, I come from Guelph, who is known as the food school. So, yes, I think we should. Absolutely. I mean, I talked about the soil degradation and all that, but we still have a lot of good stuff. Unfortunately, a lot of, the GTA was some of our best. It's under concrete now, but we still have a lot of resources, and we do excellent field production, but we can take this aspect as well, and we are, to become like the Dutch. We can be them and better. We have the space, so absolutely, we should be a major exporter.
Hi, my question is also about energy, but I've always been curious about water. With climate change and the melting glaciers, the expectation is that we would have more water. Why are we running out of water?
It's part of its location, but also quality. So we have, yes, we have a lot. Around here, we've got the Great Lakes, and if you want to build a pipeline, you can. Most places in the world don't, but Guelph, for example, is still groundwater. A city of 140-some thousand is still pumping it out of the ground, which we're fortunate we have the resources, but that can be depleted in a hurry. Some of it is agriculture. 70% of our freshwater resources are used in agriculture. Less than in heavy industry, in fact. That is where most of it goes. And there's still a lot of water, but it's degraded. Road salts, runoff from those fields that aren't cover cropped in the winter, land, just all the crap that we throw out there. So there is still water, but it's just, some of it's just polluted.
Thank you. Thank you so much. So folks, this wraps up our food series. I hope you've enjoyed it. I want to thank you for supporting this series. It's a pleasure for us to bring content like this to you in such an enthusiastic and receptive audience. If you will indulge me, I just have a few final comments. Should only take about 15, 20 minutes. We're all good? That's fine? Okay, great. I'll just carry right on. Takes a team effort to bring these series to you. And there's many folks that I want to thank, beginning with our incredible volunteers, Denise and Jill Johnson, Grace Rivers, Barb Pemberton, Sharon Brubacher, Linda McDonald, Mark Shea, Joyce McKegg, Bridget Smith, Carol Copps, and Kathy Moran. And if I've forgotten anybody that's here tonight, my humblest apologies. There would be, where would we be without our Nedra Dornkamp, who provides wonderful customer support. Big thank you to, he's here, Gord Burdick, who's the hall manager here at the center, Joel Wesley, who's not here with us tonight, but we do have Duncan and Kevin, our super audio and video team. Of course, I want to thank the amazing board, Elizabeth Ivory, Barb Woolley, Wayne Lang, Peter McLaughlin, Don McMaster, David Kent, and Joanne Sullivan. And this is her last official act with us as a board, so I just want to say a special thanks to Joanne. So as I mentioned, this is a team effort, and we're always looking for more. So here's the pitch. If you are interested in a rewarding volunteer experience, we are seeking new board members who will be part of the team developing and putting on the programs. Specifically, we are looking for people with skills in the area of marketing, websites, social media, and graphic design. And we need, as well, a new secretary to do the minutes during our monthly meetings, as Joanne Sullivan, who is stepping off the board, provided wonderful notes for us. So if you are interested, please come to talk to us tonight. And keep an eye on your email, because we will send out an email just in case you know of somebody who you think might be interested, and share that with them. I want to let you know about the upcoming series for the spring. The Northumberland Hills will be alive with the sounds of music. Our spring series, 2026 series, The Magic of Music, will help us shrug off those winter blahs and embrace the warmer climates. On a final note, I also want to say happy holidays and all the best to all of you in the coming year. Many thanks.